Hello students, once again welcome to Bholanath Academy. In this video students we are going to see the physical property of alkyl halide and aryl halide of halogen derivatives. In last video students we have prepared the halogen derivative, that is alkyl halide and aryl halide. In this video students we will see the physical properties of alkyl halide. R stands for alkyl, X stands for halide. Here this is aryl and this is halide. Okay students, so two types of halides we are having, alkyl halide and aryl halide. Their physical property students we are going to see in this video students. So here students, physical property we are going to see four physical property. First one is nature of intermolecular forces of alkyl halide. Which are the intermolecular forces are present in alkyl halide? That nature we are going to see. Understanding intermolecular forces between two molecules of alkyl halide. Which are the forces are present in this alkyl halide, that we are going to see, that is called as nature of intermolecular forces of alkyl halide. Second physical property shows boiling point of alkyl halide. What is the boiling point? How it is different in different alkyl halide, that we are going to see. Next physical property shows solubility of alkyl halide. Which alkyl halide is more soluble? Which one is the less soluble? That solubility we are going to see. That is the third property shows. Fourth property shows we are going to see optical isomerism of alkyl halide. In optical isomerism is what is the effect of light on this molecule. Understanding students? So four physical property we are going to see. In optical isomerism students, in alkyl halide we are going to see chiral atom. When the molecule will have chiral atom, then only it will show the optical isomerism. And molecular chirality, then the molecule will be, which molecule of alkyl halide will be is having optical isomerism property, that depends upon the chiral atom. If molecule is having chiral atom, then that alkyl halide will have optical isomerism. After that we will see plane polarized light. We will know what is the plane polarized light. If you want to study the optical isomerism students, these terms you should know: plane polarized light, optical activity, enantiomers, and representation of configuration of alkyl halide. How you are going to represent the configuration of alkyl halide on paper, that we are going to see. Okay students, so four physical property in this video we are going to see students in detail. First physical property we are going to see, that is nature of intermolecular forces of alkyl halide. First physical property students, nature of intermolecular forces of alkyl halide. If you have two alkyl halide molecule students, which type of forces, that is bond length, bond enthalpy, and dipole moments, these are the natures. The nature of alkyl halide depends on this. The halogen that we are going to represent with the X are more electronegative than carbon. Understanding students? If you want to study the nature of intermolecular forces of alkyl halide students, you should know halogens are more electronegative than carbon. Now carbon halogen bond, in carbon halogen bond the strength decreases with increase in size of the halogen. Understanding students? When you go from fluorine to astatine, halogens students, you know chlorine, bromine, iodine, astatine. So what happens students? The strength of the bond strength between carbon and halogen decreases with increase in size of the halogen. Now students, when you see the bond students, see the halogens atom. If fluorine size is this much, chlorine will be bigger, bromine will be more bigger. Understanding students? And iodine will be what? More bigger. So sizes go on increasing. So what will the strength in bond students? The bond strength will go on decreasing from top to bottom. Here students, fluorine to iodine, when you go, the bond strength decreases because of the size is increasing. Understanding students? Size of halogen. So bond strength is depend upon the size of the halogen. Here methyl, everywhere you have methyl, that is same group, but here students you have different halogens. Here fluorine, chlorine, bromine, and iodine. When you go from top to bottom, the bond length will decreases, the strength of the bond decreases. Now what happens students, as the sizes go on increasing? See the bond length. Other property is bond length. We are representing with picometer students. See the number students: 139, 178, 193, 214. Understand? So bond length, see the difference between carbon and fluorine. See 139. Here carbon and chloride 178 picometer. Carbon and bromide students 193. Carbon and iodide 214. So see the number students. It is number is increasing order. That means bond length increases from fluorine to iodine, methyl fluoride to methyl iodide. When you go from methyl fluoride to methyl iodide, the bond length go on increasing. Understanding students? Now what happens students? Bond enthalpy. How much heat is associated with this bond? See the students, methyl and carbon, in methyl fluoride students, carbon and fluorine. See students, when you take 1 mole of methyl fluoride, it will release 452 kilojoule. It will have this bond enthalpy. In methyl fluoride it is 452. When you go students, bond enthalpy, the heat associated between the carbon and chlorine is 351 kilojoule per mole. Yes students, in methyl bromide, the bond associated by carbon and bromide will be 293. Here in iodine 234, see the number students, it is decreasing order. Mostly it is what? Decreasing. So bond enthalpy decreases from top to bottom here, that is from fluorine to iodine. Understanding students? So see the number students, so bond enthalpy decreases. Now students, when you see the dipole moment, now see students, see this molecule is very small, so it will rotate very fast. So you will see dipole moment in this molecule will be 1.847. Understanding? Here it will 1.860, 1.830, 1.6. See students, mostly it is what? Decreasing order. To dipole moment, you see this molecule methyl fluoride will have more dipole moment as compared to methyl iodide. Understanding students? So dipole moment is mostly decreases from top to bottom, that means from methyl fluoride to methyl iodide. So students, dipole moment is what? Decreasing order. So you should know, by observing the molecule only you can explain all the physical properties students, that is nature of the intermolecular force of alkyl halide. So all are alkyl halide students, only the methyl group is same. Here the fluorine, chlorine, bromine, these are the different halides which are attached to the carbon. Second physical property that we are going to see, that is called as boiling point of alkyl halide. So boiling point students in alkyl halides are considerably higher than those of corresponding alkane due to the polarity and higher molecular mass. This is the alkane students that we are going to represent RH. If you remove the hydrogen, we call as alkyl. So students, when you see in alkyl halide, when you compare alkyl halide and alkane, the boiling point of alkyl halide is higher. Students, this higher is very important than those of corresponding alkane due to the polarity of higher molecular mass. Understanding students? Due to the polarity, here two reasons are there students. First one because of polarity, and second is because of higher molecular mass in alkyl halide. Because of that students, alkyl halide is what? Having higher boiling point than corresponding alkanes. Understanding students? Now students, within alkyl halide, when you are talking about inside the alkyl halide, for a given R group, alkyl group, so here students, alkyl group, for a given alkyl group, here the alkyl group is, this is methyl. Understanding? Within the alkyl halide, for a given R group, that is alkyl group, this is the alkyl I have taken students, methyl. The boiling point increases. See students, very important, boiling point increases inside the alkyl. Only we have taken alkyl halide molecule students. The boiling point increases with increasing atomic mass of halides. Halide students, here we have taken fluorine, chlorine, bromine and iodine. Understanding? This is the halide. So atomic mass, as see students, when you go from fluorine to iodine, atomic masses go on increasing. So students, boiling point will also increase. Understanding? By observing this fluorine, chlorine, bromine, iodine, you can see the atomic mass is increasing. That means its boiling point will also increase if it is having what? Same methyl group in all four. In all four molecules students, methyl chloride is what? Constant. But here the halides are different halides we have. So fluorine is very smallest, having less atomic mass as compared to chlorine, as compared to bromine, as compared to iodine. Iodine is having more atomic mass. So students, the boiling point increases with increasing atomic mass of alkyl due to the van der Waals and other reason van der Waals forces in order. See students, see the boiling point students, boiling point students, it is go on increasing. Understanding students? Boiling point go on increasing from alkyl fluoride to alkyl iodide. Here alkyl is what? Only one alkyl, same alkyl. Here methyl I have taken. So alkyl is constant. Here the halides are varying, fluorine, chlorine, bromine and iodine. As you go from fluorine to iodine, boiling point will go on increasing for the same alkyl halide. Understanding? Here students, I have taken the example students, alkyl halide that we are representing in RX. So here students, alkyl halide is, you have only methyl. Now here students, you have what? Different halides, fluorine, chlorine, bromine, iodine. See the boiling point students, see the number here, 194.6, 248.8, 276.6, 315.4. Understanding students? So this is the boiling point that we are representing with Kelvin. Understanding? So all boiling points, see the number students, here the number is increasing, yes or no? That means boiling point increases in Kelvin. Within our alkyl halide, our alkyl group, for a given alkyl group, the boiling points here, the given alkyl group is what? Methyl. So students, we comes to the definition by observing this example students. Within alkyl halide, for a given alkyl group, the boiling point increases with increasing atomic masses of alkyl halide and due to the van der Waals forces. In order of this students, here the RF, alkyl fluoride, alkyl chloride, alkyl bromide and alkyl iodide. When you go from alkyl fluoride to alkyl iodide, boiling point go on increasing. Understanding students? Go on increasing. Now students, boiling point rises with increasing carbon number. Now here students, carbon is go on increasing. Here carbon, only one carbon, that is methyl is having only one carbon, ethane having two carbon, propane, and this is what? Butane. We call as butyl. So here methyl, ethyl, propyl and butyl. So carbon is go on increasing. Here one carbon, here it is having two carbon, here three carbon, here four carbon. As the carbon is increasing, but halides are constant. Boiling point rises with increasing carbon number. Understanding students? So haloalkanes I have taken here students, for example methyl chloride, ethyl chloride, propyl chloride and butyl chloride. Understanding students? So as the number of carbon increases, boiling point, now see the number students, see the number is go on increasing, 248.8, 388.5, 320, 351.5 Kelvin. Understand? It is go on increasing. See the number. So students, in examination, this, if you are not able to remember the value, it is also correct. Only this statement is very important students. As you go from methyl chloride to butyl chloride, boiling point is what? Increases. Boiling point rises with increase in carbon number. Understand students? Now second students, boiling point decrease on branching due to the surface area decreases and the van der Waals forces decrease. So students, boiling point decreases when you go from, see students, it is having 4 carbon, but the arrangement of the carbon is in branch order. Understanding? All the molecules are what? Here it is normal butyl bromide. This is normal butyl bromide. Here the bromine is attached to the second carbon. Now it is coming in branching. Here more branching. As the branching increases, so students, boiling point decrease on branching. Understanding? Here in normal butyl bromide there is no branching, so boiling point is 375. One branch 364. Here it is now having 4 branch this carbon, so it is 346. As the branching increases, boiling point is also decreases. Boiling point decreases. Very important students. Boiling point decreases as the branching increases. Understanding students? All are having 4 carbon. All molecules are having 4 carbon, but students, because of the branching, the boiling point is go on decreasing. So boiling point decreases on branching due to the surface area. What is the reason students? Here 2 reasons. Because of the surface area decreases and van der Waals decrease. So because of these 2 reasons students, the boiling point decreases when you, as the branching increases. Understanding students? So boiling point decreases on branching due to the surface area. These are the reasons students. As the branching increases, surface area decreases. Because of that, students, the boiling point will decrease. Now students, third physical property of alkyl halide we are going to see, that is called as solubility. Alkyl halide and aryl halide are insoluble in water. Understanding students? Mind well, these 2 molecules, alkyl halide and aryl halide, are insoluble in water but soluble in organic solvents. Why? Because of the polar nature. Understanding students? Because of the polarity. So boiling and melting point is quite high compared to that of ortho, meta, due to the close peg symmetry. Here students, I have taken the example of aryl halide. In aryl halide students, so this is the, with respect to this chlorine, this will be the ortho, this is meta, and this is what? Para. Now you students see the chlorine, they are very very close to each other. At the time when you see the boiling point 453, as students they are go away, see the difference. Here there is a more difference between chlorine, between these 2 chlorine. See the number students, 446. Here it is what? Chlorine is what? In opposite direction. This is at meta position, this is at para position. Understanding students? So para dichlorobenzene is what? Having 448. See the number students, 453, 446, 448. Understanding students? Mostly it is what? Boiling point is quite higher. See, understanding students, as compared to this, it is what? Going to be higher. Melting point students, 256, 248, 323 Kelvin. Understanding? So boiling point and melting point is quite high compared to that of the ortho and meta. This is ortho students, and this is what? Meta. The boiling point is quite high compared to that of ortho and meta due to the close peg and symmetry. See here students, they are very close to each other, that we call as close peg. We call as what? Close peg. And here students, it is symmetrical. Understanding? Because of the symmetry. Symmetrical students, and this is what? Unsymmetrical. These 2 molecules what? This is unsymmetrical. Understanding students? So boiling point is what? Is quite high as compared to this. This is 446, this is 448. It is quite high as compared to unsymmetry. So symmetrical alkyl halide is having what? More boiling point and melting point. Understanding? So boiling point of symmetrical aryl halide is what? Having more melting point and boiling point as compared to unsymmetrical. So this is all about the melting point and boiling point of alkyl halide. That fourth property we are going to see, that is optical isomerism alkyl halide. Optical isomerism is very useful to understanding the nucleophilic substitution reaction of alkyl halide. So this, if you know the physical property students, you can understand the chemical property, that is nucleophilic substitution reaction, you are able to understand. If you know the physical property, optical isomerism in alkyl halide. So to understand the nuclear substitution reaction, this physical property of alkyl halide you should know. So optical isomerism, optics means light. What is the effect of light on this alkyl halide, that we are going to see in this. In optical, if you want to study the optical isomerism of alkyl halide students, you should know chiral atom. What is chiral atom and what is molecular chirality? So students, in alkyl halide, which atom, carbon atom is chiral atom? Because of chiral atom students, if the molecule is having chiral atom, then that we call as molecular chirality. So carbon atom in a molecule of alkyl halide which carries 4 different groups atom is called chiral carbon atom. So in alkyl halide students, in alkyl halide, if the molecule is having chiral carbon atom, so the molecule is called as molecular chirality. Now what is the chiral carbon atom students? So students, that carbon in a alkyl halide which having different group is called as chiral atom. Called as what? Chiral carbon atom. So carbon, say for example students, in example you can say 2-chlorobutane. It is alkyl halide students. Since it is a butane, so you will write how many carbon? 4 carbon. At carbon number 2, from this side or this side, you can see this, there is a chlorine is attached. Now fill the valency with hydrogen students. So here 3 hydrogen. Carbon is tetravalent. Now 3 valencies already occupied, 1 valency with carbon. Here 2 valencies occupied, 2 hydrogen we have to add, here 3. So this is 2-chlorobutane. Understanding students? When you see the carbon number 2 students, this carbon number 2 is having different group. Understanding? This is methyl group, this is chloride, this is ethyl, and one more, that hydrogen is called as what? So all are having, this carbon is called as chiral carbon because it is having different groups. Understanding? This you can also write like this students. So carbon, understanding students? Here this is 2-chloro, here hydrogen I am writing like this. So students, CH2, CH3. So this is the example students, 2-chloro. This is the molecule students. This molecule is alkyl halide. This is the example of alkyl halide students. Example I have written students. So example 2-chlorobutane. Here this is carbon number 2. This is carbon number 1, 2, 3 and 4. Carbon number 4 is having all the tetravalency of carbon is having different group. This is the ethyl group. This is chloride. This is methyl, and this is what? Hydrogen. All are having different group, which is attached. All the valency of this carbon is having different groups. That is why this carbon is called as, carbon number 2 is called as chiral atom. Chiral carbon atom. Understanding students? That is also showing with symbol asterisk. This is the asterisk symbol we are showing. Understanding? Because of this chiral atom, this whole molecule is what? It is having optical property. Understanding? If molecule is having chiral carbon atom, then this will show the optical properties. Otherwise this alkyl halide will not show the optical property. What is the optical isomerism examination students? Sometimes they are asking. So the stereoisomerism, in which stereo means there is a moment in isomerism. The stereoisomerism in which the isomers have different spatial arrangement of groups or atoms around a chiral atom is called optical isomerism. What is optical isomerism students? It is a optical isomerism is nothing but it is a stereoisomerism in which the isomers have different spatial arrangement of groups atoms around a chiral atom is called as optical isomerism. Example students, again example I am taking alkyl halide. Which type of alkyl halide students? 2-chlorobutane. Again students, because 2-chlorobutane is having what? Chiral atom, so this is, it will have optical isomerism. So students, here students, 2-chlorobutane, carbon is what? Having 4 carbon students. Okay students, all are carbon is tetravalent. Understanding students? Now fill the valence at carbon number 2. 1, this is carbon number 2, 3, 4. 1, 2, 3. At carbon number there is a chlorine is attached, other valency by hydrogen. Okay students? So this is the structural form of 2-chlorobutane students. You can also represent this like this. Carbon, this carbon is chiral carbon atom. You can put the asterisk on this carbon. Why students? Because it is containing hydrogen, and this you can also write C2H5, and this is chlorine, and here it is CH3. So this carbon is having different group. The hydrogen, ethyl, chloride, and here it is what? Methyl. If molecule is having chiral carbon atom, that molecule is called, that alkyl halide is what? Chiral molecule. Understanding students? So 2-chlorobutane is what? It will possess optical isomerism because of that it is having what? Different groups, hydrogen, ethyl, chloride and methyl group. In 2-chlorobutane students, you can also write this. This is the structure of 2-chlorobutane students. Now if you keep the mirror here students, you will find methyl group will come on this side. This is CH3 and hydrogen will be as it is chlorine. Understanding students? They are non-superimposable mirror. This is called as what? Non-superimposable mirror image of each other. So students, 2-chlorobutane, if it is a chiral molecule, they are what? Non-superimposable mirror image of each other. So students, 2-chlorobutane is having what? Non-superimposable. When you see the mirror image of these molecules, first and second, these two molecules, that is 2-chlorobutane, it is also 2-chlorobutane. So in first students images, they are what? They are non-superimposable mirror image. If you keep this molecule on these students, they will not overlap. Understanding students? Because of this chiral carbon they are non-superimposable mirror image of each other. This is the property, students, optical property, students, that is called as non-superimposable mirror image of each. If it is a optical isomers, students, they are non-superimposable mirror image of each other. Next, students, terms that is called as plane polarized light. Which light we call as plane polarized light, students? When ordinary light, this is the ordinary light, students, is passed through Nicol prism. This is the Nicol prism, students, an oscillation only in one plane. See this here, the light is oscillating in all possible direction. But when this light, ordinary light, is passed through Nicol prism, students, it will oscillate in only one direction. Light having oscillation only in one plane at perpendicular direction of propagation of light is known as plane polarized light. Understanding, students? In examination they are asking what is plane polarized. For 2 marks, students, they may ask in examination what is plane polarized light. You have to write the definition as well as this diagram. When ordinary light is passed through Nicol prism, oscillation only in one plane, this is only one plane, students. Such a light having oscillation only one plane perpendicular to direction of propagation of light. If the light is propagating on these directions, students, they are perpendicular to each other. Understanding, students? This is the direction of propagation of light and they are what? Perpendicular to here. So this light is known as what? Plane polarized light. When a ordinary light is passed through Nicol prism, oscillation it will oscillate only one direction, and oscillation is perpendicular to the direction of propagation of light is known as plane polarized light. Understanding? So this light is called as what? Plane polarized light. This is ordinary light. Now this light is called as plane polarized light. Third terms in optical isomerism, that is called as optical activity. When you can say alkyl halide is this, which alkyl halide is having optical isomerism? The property of substance, here the substance we are taking, that is alkyl halide. The property of substance which rotate the plane polarized light, this is plane polarized light, students, that already have seen the definition. The property of substance, now we are going to see this is the substance, students. The substance is mostly we are taking here as alkyl halide. Property of substance which rotate the plane polarized light, plane of polarization of incident plane, is known as what? Is known as optical activity. Incident plane polarized light, this is light is incident. This light is what? Incident light. This incident light is now, it is rotating in dextrorotatory right hand side. If it is rotating left hand side, we call as Leo. Right hand side, students, we call as what? Dextro. And if it is rotating in left hand direction, the substance we call as what? Leo rotatory substance. Understanding? So this substance, when this substance is dextrorotatory, when it will rotate the light, this plane polarized light, if it is rotating on right hand side, the substance, this substance then we call as dextrorotatory substance. If substance is rotating, this substance, if it is rotating in this direction, in left hand direction, then it is called as, this substance we call as what? Leo rotatory substance. So when this substance is dextrorotatory, when the plane polarized light, if this substance, when this light is fall on this substance, when you see the light, plane polarized light, when plane polarized light is rotating in right hand direction, then this substance is called as dextrorotatory substance. When the substance is rotating in this direction, so this substance is called as Leo rotatory substance. Understanding, students? When the substance, the property of substance which rotate the light is called as optical activity, and the substance which rotate, if the substance is rotating the light in right hand direction, is called as dextrorotatory substance. If the substance is rotating the light in left hand direction, is called as Leo rotatory substance. Understanding, students? So this is all about the optical activity and the substances. Which substance rotate the light, that means the substance is having optical active property. Understand? Otherwise, if it is not rotating, this is optically inactive substance. Understanding, students? Now here the substance, because it is rotating, we call as optical active substance. The isomerism in which isomeric compound have different optical activity is known as what? Optical isomerism. Understanding, students? This type of isomerism we are getting dextrorotatory and Leo rotatory is called as what? Optical isomerism. In enantiomers, sometime in board examination they are asking for 2 marks. So optical isomerism which are non-superimposable mirror image of each other are called as enantiomers, enantiomorphs, and you can also say optical antipodes. Understanding, students? The optical isomers which are non-superimposable mirror image of each other. Example, students, I have already explained, that is, this is the alkyl halide, students. The 2-chlorobutane is alkyl halide, it is type of alkyl halide. Now, students, I have already explained the structure, students. This is the carbon having 4 valency, students. Here also carbon having 4 valency. Now, students, structure of 2-chlorobutane, students. Here will be hydrogen. Here this is carbon number 2. Here C2H5, and this is what? Methyl. This is the structure of 2-chlorobutane. When you see when you keep the mirror, students, here, what happens, students? C2 will come on this side, and this methyl will go on this side. Hydrogen and chlorine will be as it is. Understanding, students? Because it is a chiral carbon, you can put the asterisk symbol. Understanding? 2-chlorobutane. When you see the, students, when you keep the molecules on this, what happens, students? They are non-superimposable mirror image of each other. Understanding? They will not. See, students, on ethyl chloride, if you keep this molecule, methyl chloride will come. and they are non-superimposable mirror image. So this molecule, when you see the structure students, by observing the structure only you comes to know the 2-chlorobutane. You comes to know the 2-chlorobutane is what non-superimposable mirror image of each other. Therefore, this isomers, these two isomers. This is first isomers. This is first isomers students, and this is what second isomers. So these two isomers are what? This molecule 2-chlorobutane is what? This is called as enantiomers. It has property that is called as what? Enantiomers. So optical isomers which have non-superimposable mirror is called as enantiomers. We can also say enantiomorphs. We can also say optical antipodes. So understanding students, so 2-chlorobutane is what? Optical antipodes. They are in enantiomers, or you can also say enantiomorphs. An equimolar mixture of enantiomers, dextro and leo is called as racemic mixture. Say for example students, again you can see the example of 2-chlorobutane, or you can also say secondary butyl, which type of alkyl, and chloride. Understanding students? Same structure students. This is C2H5, this is C2CH3, hydrogen and chlorine. If this is dextrorotatory substance students, if it is dextro, this will be what? Leo. If you are taking equimolar, 1 molar, and this is also 1 molar. Dextro and leo, if you are taking 1 molar of 1 liter, if you are mixing, and after the mixing students, whatever mixture you are getting, that is called as racemic mixture. So equimolar, all are having same molar. Example students, I have taken for example 1 molar of dextrorotatory substance and 1 molar of leo-rotatory of 2-chlorobutane. So equimolar mixture of enantiomers, dextrorotatory or leo-rotatory, is called as what? Racemic mixture. Understanding? When you mix these students, the substance will not rotate the plane polarized light. So after mixing these two students isomers, the equimolar mixture of these two, dextro and leo, the mixture will be what? Racemic mixture. The racemic mixture is what? This racemic mixture is non-optic. It is not optically active. Not optically active substance. Equimolar mixture of enantiomers, dextro is called as racemic mixture. What is the racemic mixture students? Equimolar mixture. Equimolar mixture of enantiomers is called as racemic mixture. We call as DL. So understanding, after mixing this mixture we call as DL mixture. So DL mixture is what? Racemic mixture. Representation of configuration of alkyl halide. So students, here simple example I am taking students. So 2-chlorobutane. 2-chlorobutane students, feature projection. If you want to write the feature projection formula students, you have to represent like this students. Carbon, 4 carbon. Carbon is having 4 valency students. See, here will be CH3, C2H5, chlorine and hydrogen. So here we are representing with cross like this. So this is cross projection formula that we can represent like this: CH, C2H5, Cl, and this is CH3. Okay students, you can represent. So this is called as cross projection. This is also called as cross formula. Cross formula. Understanding students? So this is 2-chlorobutane students. You can represent like this by put like this. That means carbon. You have to consider this point as a carbon. So that is why it is called as cross. We are making cross. That is also a feature projection formula is also called as cross formula. Cross formula. Understanding students? So 2-chlorobutane. If you want to represent in feature projection formula, you can represent like this. Understanding students? So this is our normal representation of 2-chlorobutane. If you want to represent this 2-chlorobutane in feature projection formula, this way you have to represent. Same compound students we are going to represent in Wage formula. Now you have to represent with Wage formula students. How you are going to represent? This is the carbon students. Now here you have to represent the two plane like this students, and the carbon which is back side students we are representing with this. Okay students, so this is hydrogen and this is chlorine students. You can represent C2H5, this is CH3. Okay students, so this way students you can represent the Wage formula of 2-chlorobutane like this. Understanding students? These two lines are on the plane, these two are on the plane, and this is what back side, and this bond is what front side. So this way students you can represent the 2-chlorobutane in Wage formula. This is very important for the examination point of view. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.